A very good evening to all of you. It's a pleasure to have Professor Mayank Vahia with us today. He's a retired professor from the Department of Astronomy and Astrophysics at the Tata Institute of Fundamental Research in Bombay. He retired from there in 2018. And after that, he started a School of Mathematical Sciences at the Narsimonji Institute of Management Studies. He completed his 3-year tenure in 2021 and is now retired, as he says. But he keeps reading, and as you've seen, he makes the time to speak to us. He spent his earlier years making telescopes that were flown on American, Russian, and Indian missions. In recent years, his interest has expanded into the history and philosophy of science in general, and astronomy and in particular. He also initiated the astronomy and junior science Olympiads in India and led the former for more than a decade. You can actually read a lot of his articles, which he has authored in this website called harappa.com on the history of science, on the history of particularly the Indus Valley civilization and its script. So it's a real pleasure having you with us today, Mayank. And thank you very much for speaking to us. So over to you.
Thank you very much, Saikya. Thank you very much. It's a pleasure to be here, and I'm grateful to Saikya for giving me this opportunity, and to Ayuka and to UGC, of course. Without that, this wouldn't have been possible. So I'm going to talk about Shunya or zero. There is a folklore which says that India should be credited with discovery of zero. And what I'm going to show you is that that statement is more profound than simply saying that Indians were the first ones to use zero. In fact, Indians were not the first ones to use zero in arithmetic. And yet, for very justifiable reasons, the credit is given to India for having discovered zero, if you wish. We didn't invent zero, but we discovered zero, and that is what I will come to. So the entity called zero is a very strange entity. It represents nothing. It is an idea that represents nothingness, and that is something strange. It elicits surprisingly strong emotions in various cultures, and I will, by the time of the end of my lecture, you will appreciate what I mean by this little statement. As we will see, the Indian culture readily embraced this idea of zero, while other cultures, especially the Europeans, hated the idea from the bottom of their heart. It will be surprising how much they resisted, and that's what I will come to in the later part. And we will see how and why this happened. So let us look at zero. Acceptance of zero as an entity and as an entity that represents nothing requires a kind of cultural orientation. And the idea of facing zero and handling zero itself also requires significant cultural orientation. Zero is very natural to Eastern thought, while it is completely antithesis for Western thought. So when we were taught in the school, for example, we were told that natural numbers go from 1, 2, 3, 4, and then the whole numbers go from 0, 1, 2, 3, 4, and so on. In fact, as far as India is concerned, natural numbers is 0, 1, 2, 3, 4. The problem was that in Western philosophical thought, the supreme being pervades everything. And hence there is nothing like there is no entity where there is nothing. And that idea was so strongly embossed in Western thinking that they would not accept zero, and they wouldn't accept zero for a long time. And I'll come to that in a minute, except in the arithmetic sense of the word. In the sense that 5 minus 5 equal to 0 is something everybody accepted. But for example, the Greek number system, IV, XL, CDM, doesn't have 0. And there is no way of representing 0 in that number system. And that actually is not a casual absence. It is a very profound absence. And I'll come to that as we go through. For Indians, 0 was something that was real, viable, and useful. Nothingness actually existed and could be used in a variety of environment to do a variety of things. And that is where the beauty lies. In the present talk, I will talk about various aspects of null, invented, discovered, thought about, whatever way you want to say it, and how various cultures responded to it, especially why India gets credit for it, and what happened to Western philosophy after that. Equally important, how thinkers of different mindsets reacted to zero when they came across zero. So Indians were certainly not the first ones to use zero. Sumerians and Babylonians in 3000 BC have used location-based number system and had zero as a placeholder. We are not so sure whether Harappans had it, but Harappans were anyway 2700 BC after that. So Sumerians are well ahead of us in time frame, and they were the first ones to use the placeholder zero. In fact, quite interestingly, that instead of using the decimal system, which we use because we have 10 fingers, they used actually 60 base number system. And they use 60 base number system because 60 is divisible by 2, 3, 4, 6, 10, 20, and 30. So it was useful for mercantile purposes to have the base as 60, so you could get several fractions of it in as you needed in the trade. But they thought little of it. They just thought of it as a number for arithmetical purposes. And they originally used blank to denote zero because zero was nothing. Then that zero became confusing. So they eventually came up with this sign to represent zero. And that itself is a rather interesting ambiguous sign. Note that the symbol of zero is not needed. So in early Indian literature, for example, you get statements like 2003 and stuff like that, where zero is not required. You can say 2003 without having a symbol for zero. It is only when you write it as numeric that you need the symbol for zero. So you could, in principle, even Sumerians and others would talk about zero in arithmetic sense of the word. And when they did the arithmetic tables, etc., they either initially used blank, then it became confusing whether it was a spacer or whether it was a zero entity. So they came up with this sign. But it's worth remembering that original use of zero is arithmetical. It eventually changes, the entity zero changes its nature much late in a very complicated manner, basically. So zero as an entity, let us look at. So Babylonians, like I said, use this symbol for zero. Mesopotamian 6th century BC actually used this sign as a zero. It's a rather complicated sign. Mayans use zero as this, or this, depending on their context. Khmer, 6th century AD, used this dot as zero. While Bakshali manuscript, 224 AD, for the first time gives you the entire numerics 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, where 0 is still a dot. Eventually, that dot writing was also becoming confusing, so the dot was expanded into the oval shape that we see today as a number 0. So why do you need a 0? Why was India credited with 0? The reason why India is credited with 0 is more complex. Okay, like I said, the first users of arithmetic 0 were before us. The genius of Indian civilization was in the idea of merging Shunya and Shunyata to create a completely wider worldview. The Europeans didn't do that. The idea of Shunyata itself was an antithesis to them. The worldview that admitted of nothingness or void or emptiness as a natural entity. And that's a very profound thought. And I'll come to that a little later. The concept came up in a variety of environments, and all these environments to fade to each other. So well before the algebra of zero was invented in India, the very nature of handling zero as an entity was very familiar to the people. And therefore, when it came to the algebra, they could as easily use it without feeling any resistance. The interplay between these various concepts of zero in India is very fascinating. And that's what I'm going to talk about. To understand this, we need to step back on how humans perceive nature. So, for example, fundamentally, Indians made mathematics as a language rather than a tool. For arithmetic purposes, for business purposes, it was a tool, but Indians explored mathematics as a language. So they were just interested in various curious series, various sequences, etc. And they just enjoyed. So it was not used for mechanics or something like that. It was used in astronomy because astronomy was the representation of heavens, and therefore they used it for astronomy, and they used mathematics for pure pleasure of mathematics. And within this work, one can see the basic ideas of differential algebra by the time the Kerala school comes of 13th century AD. Boolean logic is also there by the time of 13th century AD. Set theory, the basic profound ideas that something can be divided as set theory, can also be found in this structure. Algebraic logic, reasoning to obtain and manipulating equations of with free variables is something that was done in India. So let us see how this whole came about. Why were Indians so comfortable with mathematics of zero, and in general the concept of zero? So one has to worry about the rise of human perception of intellect. Once humans' thinking had reached a level of complexity which exceeded the need for survival a few thousand years ago, they began to speculate on their existence. And while I will confine our discussions to how thoughts developed in Europe and India, actually the canvas is much larger. It's quite likely that early common ideas arose well before people separated some 15,000 years ago. When the Indians and the Iranians and the Europeans separated out, carrying the common language that we call the Indo-European language, from which Sanskrit comes and so on. The first idea about nature works included the imageries of Mother Earth and Father Sky. That's very common because Earth, for example, nourishes life, but Earth cannot produce life until the rains from heaven come. And there's an obvious association with birth and Mother Earth's womb, etc. It's a very natural starting point for all religions, which is to have Mother Earth and Father Sky. Then all creatures believed in one form or another of the existence of this great. All cultures believed in some form or the other of the existence of this great God. That was the proverbial one, the one who created everything. The great God then created the universe. If you go by Indian philosophy, it says by the order of his wish and so on. And I will come to that Nasadiya Sukta in a minute, where you actually get a definition of how they thought the world was created. The one that created the many variations of life. The one, therefore, pervades everything and remains even when everything else is gone. This is typically the first seed of human pursuit to understanding creation. But there's a cultural difference. So there are more important differences and divergences between Europeans and Indians. Indians incorporated the idea of null as being real. So the universe comes from nothing. There existed, there is an explicit statement in Rigveda which says there existed nothing. And then out of, I will come to that Nasadi Sukta. We'll just enjoy it when it comes. So Vedic people themselves had no permanent places of worship. The oblations they offered to at Havans, etc., were performed at that place at that time. Then the place was simply wound up and they left for somewhere else. So there was no permanence of religious temples and so on. And so their own god was also formless. For the Murti Puja, for which Hinduism is much condemned, is a very later addition to Hinduism. It's a post-Buddhist tradition. Original form in Rigveda actually has gods who are completely formless and who can be only reached through sacrificial fires and so on. So they had also assimilated ancestor worship. Again, ancestors did not exist, and the idea that something null like the ancestors could be worshipped is a part of the same story. This is not true for the European, to whom life without the one was unimaginable. One was the smallest of small numbers for them. Everything there was one. Zero made them very uncomfortable. So the idea of null. The reason why I'm going through this somewhat similar statements for sometimes is because I want you to appreciate the depth of this idea. Indians were comfortable with the idea of vanishing or non-existent entity. To them, it represented an amorphous, undefined entity that could be experienced in absence. Null entity represented something that did not exist or had ceased to exist. This was an interesting idea that came up in a variety of contexts, and we'll look at some of these contexts. So let us look at the forms of Indian zero that Indians used. They brought the first use of concept of zero not as shunya but as shunyata. And they visualized a non-existent entity from which the universe came into existence. It was not a religion as this unmanifested one is not worship. The universe was created by this unmanifested one who is never worshipped in the religious text. He's just too supreme to be touched. The world does not know of its thoughts. We do not know the reason for doing this. We do not have dialogues with him. He does not give anything to us. No prayers are offered to him. No temples are made to this great one who created the universe. So the first idea of null is the description of this great creator who is beyond existence and who is time independent. In sciences, there is nothing time independent. In religion, you can have time independent. So the idea of completeness of this great one, Purnat Purnamidam, is something that comes from there. And the idea of moksha is also the similar one. where in Bhagavad Gita, God says that once you reach nirvana, you actually merge with the great one. But you do not worship that great one. So there is Nasadiya Sukta, Rigved 10:129, 1500 BC is the general date for Rigved. And it says, it begins by saying that there was neither being nor being. Null existed before existence came. Okay. There was no air, yet no sky beyond. What was its wrapping? Where and in whose protection? Was water there, unfathomable and deep? And it says there was no death then, yet there was no deathlessness. Of life, of night and day, there was not any sign. The one breathed without a breath by his own impulse. Other than that, there was nothing at all. The darkness was then wrapped all around darkness, and all was water indiscriminate. Then that which was hidden in the void, the one emerging, stirring through the power of his ardor, came to be. So out of null, the first great God comes. In the beginning, love arose, uh, which was the primal gem of the cells of the mind. Okay, the seers searching for their hearts for wisdom discovered the connection between being and non-being. A crosswise line cuts across being and non-being. What was described above and what was below. Bearers of the seed were and might and mighty forces thrust from below and forward to move above. Who really knows? Who can presume to tell us? Whence was it born? Whence issued this creation? This and then the poet says, even the gods came after its emergence. Even then, who can tell us from where they came? And then they speculate that out of which the creation has arisen, whether it held firm or it did not, he who surveys the highest heaven, he surely knows. And then the poet doubts that maybe even he doesn't know. Within this Nasadiya Sukta lies a profound set of philosophies which would drive Indian thought for, well, millennia, if you wish, 1500 BC to today and more. But that's a profound. So there is a whole bunch of, one can write a whole commentary on Nasadiya Sukta about the philosophical impact that it had. So that is the first zero that you come across, the one that was created, and it is defined in terms of there being neither being nor being, and all the opposites did not exist. So the only way of describing this God was through neti, not this, not that. And it is out of order that it comes. Then the Indian approach to knowledge has been more meditative than argumentative. And I will come to Indian logic later on. The religious practices of Veda and post-Vedic period emphasize on meditation. You do not learn through words, you learn through meditation. The fundamentally different from the practices where the development was thought was largely through discussion. There are beautiful debates and discussions in some of the ancient literature, but the whole idea was meditative. The meditative approach brought the second form of religious null, because in meditation, by definition, you are supposed to prevent the brain from thinking. The whole idea is to get null. The idea is to stop thinking. The idea is to prevent thinking, and the idea is to not even let mind wander, to consciously prevent it from thinking. The idea of the second null, where you make sure you try to force the brain to stop thinking and null it, as it were. So there's a second, in religious structure, that is the second internal structure. Then the Vedic people amalgamated their nomadic lifestyle with genuinely sophisticated language, imagery, and philosophy. The biggest problem was to preserve these creations in a nomadic environment. So they created a language that was grammatically precise and could actually preserve their creations over space and time, even when they were transmitted through speech rather than written down. And so, if you look at Rigvedic Sanskrit, there are actually 6 levels of search of ensuring consistency, so that a bad pronunciation or a misplaced word can immediately be caught, and you would realize that there is some error. And so the precision of transmission was given a lot of emphasis. So, for example, a Tamilian or somebody from South India has completely different accent from somebody in North India. But when they recite Rigved, it will be identical whether it is on the banks of Ganges or it is in some temple in Tamil Nadu or any other place in South India. So that precision required non-trivial developments. The best thing was to do, obviously, was to use verses and rhythms and music, so that poetry carries the strength of providing internal consistency and so on. So there are various chandas and in which it is written and so on. And the auditory sensitivity is so much that you will catch up a error in recitation very quickly. But that required something more. The language had to be precise, and so the creating in the form required verses and stanzas, but it also required precision and economy of words. And economy of words is phenomenal in the Rigvedic literature. The idea of sandhi therefore allowed compressions, compressing information into the stanza. And I'll give you an example of this in a minute. It permitted conservation of information, but required a technique whereby two words could be merged into together. So, for example, numbers were represented by words, and Katapayadi system there is there, and so on. They would eventually create a script that allowed conjunction of vowels and consonants and accurately represent the sound. Representation of sound was the most important thing. So Indians have the only script which is called abugida or alpha syllable, where the vowels and consonants are separately represented in such a way that it becomes unique. In English, of course, when you write I, whether it is E or E, is something that we do not know. Whether you, when you use A, you don't know whether it is to be pronounced as O or A. Only by context you will know. In Sanskrit or in even in anything written in Devanagari script, there is no such ambiguity. In fact, Rasva and Dirgha, the fine changes in pronunciations are also very meticulously marked out. So they developed a script eventually which would make sure that this kind of representation would work. But Sandhi is an interesting idea. So Abugida eventually comes in all Brahmi family of scripts, um, and there is only one script in Ethiopian Aboriginals that uses this, and is probably an Indian influence of trade and so on. And there is some odd Canadian Aboriginal syllabi that do that, but otherwise it's a property of Brahmi series of scripts all the way to Devanagari and more. So Panini came out with this idea of formalizing the rules of Sandhi. So Panini uses the word lopa, where a sound is supposed to disappear and become null. Okay, so null is then used effectively to lay out the rules of Sandhi for creating new words and even extending the meanings of the words and compacting the language. In Tamil grammar, the disappearance of zero itself actually has multiple forms. So there is a zero which is asharnam. You do not hear it. There is non-pronunciation of a particular word. There is non-availability of certain word, and there is a non-existence of certain words. It just doesn't exist. And then there is loss of sound of certain word. And I'll come to an example of this in a minute. The 5 ways of eliminating sounds are very precisely defined and very precisely done, so that coding and uncoding both of what is written becomes easier. And even those who are not able to decode will actually be able to reproduce what they have learned without loss of precision, precisely because this kind of sandhis were created. So I have a friend called Vate Gaonkar, which Kar is a very common form of name giving in Maharashtra. So I will take that example first in Marathi and then in Hindi to show you what I mean. So Vate Gaonkar essentially means Vatet Yenara Gavat Rahnare, a person living in a village along the way. And look at how it is compacted. In Hindi, it would be रास्ते में आने वाले घर में रहने वाले. And look at how much is there. So Vatet and Gavat are themselves sandhis. You remember that. But in conjunction, for example, to from Vatet and Gavat simply disappear. That sound is lost. Yenara is not available anymore. That word doesn't exist in Vategaonkar. Ranare is non-existent again because it is not necessary. Gavat is replaced by is a replacement for Gavat Rahanare. It is a sandhi, and eventually Aswaram is replaced by Kar, and Gavat becomes the ta of Gavat becomes anucharan, unpronounced, and eventually you end up with a word called Vategaonkar, and you can spell it as Vategaonkar or Vategaonkar depending on your choice. And for the English word Vategaonkar. But the village is written as gaon in Hindi and gao in Marathi. So you can choose any. So a Maharashtrian person would more use Vate Gaon Kar than Vate Gaon Kar. Sanjay is the name of that friend of mine. So Sanjay is probably easier than going through the entire complexity of Vate Gaon Kar. But Vate Gaon Kar, to take it in Hindi, Vate Gaon Kar means रास्ते में रहने वाले गांव में आने वाले रास्ते में आने वाले गांव में रहने वाले. There Vat of Marathi becomes Hindi Rasta. The conjunction is as follows: may disappears. आने वाले is completely non-available. रहने वाले is non-existent. And गांवकर is replaced by uh, is a replacement for गांव में रहने वाले गांवकर. And the equivalent in Hindi would be गांववासी or गांव वाले. May completely disappears from the words. And so eventually Vate Gaonkar signature surname would be translated as Raste Gaonkar, Raste Gaonwasi or Raste Gaon Wale, depending on what your personal pronunciation of Hindi is. And like I said, Sanjay is probably easier way of addressing Vate Gaonkar. But this kind of Sandhi for the first time allows you to make words disappear. The idea of null culturally is very, very common for Indians. Indians don't get idea of this disappearance of things and non-existence of things uncomfortably at all. And Panini, of course, is 2nd century, 6th century BC. In northern India, incidentally, we have the tradition of putting I or double E. So you have Allahabadi, Banarasi, Bihari, etc. But you don't have you have no Varanasi. So Varanasi may it will become Varanasi Vasi. So while whatever Kar is called, so there is Mumbai Kar, Pune Kar, Nagpur Kar, whatever you wish. In Maharashtra is applied extensively to humans. I and E in UP are very are less versatile and more like, and also it is used in different contexts. So for example, Banarasi does not mean a person from Banaras. It can also mean a sari from Banaras. So it doesn't have the same rigidity that Kar has in Maharashtra. Yes, in some situation you use Vasi or Rahne Wala, but though they are not as fluent as the Kar in Marathi, and the Kar in Marathi, that entire structure is created as per Panini's grammar of 600 BC. Because this idea of null is something that becomes natural to India. Then, so Panini's zero, like I said, is a zero of linguistic and grammatical studies. Zero is employed in grammatical operations. It is used in so if you think of many sandhis that we routinely used in our vocabulary, you will realize that some of these things are there. In English, these examples are very rare. So 3 times is called thrice, and so where double E times, 3 times becomes thrice ICE. And there are very few examples. Twice and thrice are essentially two examples where one can see that. Well, in Hindi it is, well, Sanskrit it is routine, and therefore it has, the language has that precision that it does. So lopa is a form of null. Then there is another form of within this category, which is mantras. There are many verses in at least Samved, etc., where the words have no meaning. The words that are used have no dictionary meaning at all. They are simply rhythmic content in order to synchronize and create a music which is central to Samved, of course. So in Havans, etc., while Rigvedic priests are reciting mantras, their corresponding Samved priests would simply fill in with that music. There is null there. There are wordless sounds that come in, and they are not random, of course. They have a very high degree of precision about how that verbalization is done, how that null is done, how that sound is created, which may have no grammatical meaning. Yeah, before we go on to the other forms of zero, I want you to pay a little attention. In the 21st century, to something else. 21st century theory of knowledge says that you can get knowledge through sense perception, reason, emotion, faith, imagination, intuition, memory, and language. While Vaisheshika, 2nd century BC, and I'm going to discuss this book at length because I love this book. It says perception, the only way of getting knowledge is through perception, inference, analogy, derivation from circumstances, non-perception or negative cognitive proof, non-existence, and verbal testimony of a learned person. So so these are 1, 2, and 3 are 1, 2, 3, and 6 are included in the Nyaya system, and we will look at Vaisheshika in detail. The interesting thing is that Vaisheshika does not allow emotion, faith, imagination, and intuition as a way of getting knowledge. On the other hand, they add Arthaprapti and Anuplabdhi as valid ways of getting knowledge. It's a far more precise definition in Vaisheshika than what we use in 21st century. So, Zero of Science and Vaisheshika is the book that is 2nd century BC. Um, the first genuine textbook of science that existed anywhere. Now, the problem with India has been that we have been emphasizing our religious literature a lot to create an identity for ourselves. But the secular literature in Sanskrit is also phenomenal, extremely powerful, unfortunately poorly highlighted. But Vaisheshika is an example of a purely secular text. So it doesn't call upon God, it doesn't talk about God, it doesn't bother about any supreme being, it does not worship anybody, it does nothing. It goes ahead straight away and tells you what physical universe looks like. It gives a very secular explanation of the universe works. Okay, it comes across the several problems of formulation which it uses, and that's simply fantastic. Thus, it's a source of physical universe is solid, liquid, air, fire, and space, as you know, as the Panch Mahabhut. And the idea of Panch Mahabhut starts with Vaisheshika. And the source of life is Atma, and they define Atma as anything that is living. And they realize that there is a difference between animals and plants. So they add an additional property of mana to animals. And then there are four of the five Parmanus. The space doesn't have Parmanu, but solid, liquid, air, and fire have Parmanu, as they call it, the smallest entity. And I'll come to why they have that. Space, Atma and Mana do not have atoms. They are essentially void. And there are different kinds of non-existences that are there. So Vaisheshika classifies non-existence in four ways. It says prior non-existence, something that never existed. Posterior non-existence, something that disappears. Reciprocal non-being, in the sense that if A is absent as B, and then B is absent as A. So there is that reciprocal non-being. Then there is absolute non-existence. That the child of a barren woman, as the example goes. Absence of something that neither has existed nor will ever exist. The absolute non-existence is included as a primarily to underscore the non-absoluteness of prior and posterior existence. Something may appear and something may disappear, but something that never existed. The idea of null is built into this very understanding of the working of nature. This time it is not religion dependent. So Vaisheshika defines Parmanu in a very interesting way. It is an indivisible and eternal entity, and it is distinct. There are only four kinds of Parmanus for the four of the five Panch Mahabhut. And the modern definition of atoms and periodic table, etc., is very new. They knew only solid, liquid, gases, and ether. They did not know of the periodic table. So this adaptation of the word atoms to anu to mean atom and parmanu to mean nuclei is a very 20th century reinterpretation of that word. The original word of Parmanu is very different. Parmanu is the smallest entity that has the specific properties of that particular object. And by definition, they are space shapeless, pointless, soft object that manifest in other form. And the reason why Vaisheshika or Kannada comes up with this argument of Vaisheshika is also interesting. Of Anu is also interesting. He argues that if matter was infinite, I could take a piece of stone and keep on chopping it until it kept on producing infinite amount of matter. So I could make a whole mountain out of a piece of stone, which obviously is not possible. So there is this argument of inconclusiveness, and therefore he says that there must be a smallest entity beyond which I cannot get an infinite pool of that material. And that is what he calls Anu. And Anu and Parmanu, etc., come from that idea. So they are not the idea of atom and nuclei that we have in 20th century. It is readaptation of those words, not with their meanings. In nature, Anu is another null. Therefore, when you reach Anu, you now reach a point object. Only a collection of Anus will eventually give you the property of the material that you have. Okay. So Brahmagupta 0, then comes from Brahmagupta 0. Brahmagupta 0 says Indian mathematics treated 0, like I said, mathematics as a language. So they were just trying out. So mathematics is a very clear grammar. It is equal to, plus, minus, and various statements. It has various complex words like sine function, theta function, and so on. And it has it has sentences like 5 is equal to 3 plus 2 is a sentence as far as mathematics is concerned. So mathematics is a language as far as early mathematicians are concerned. Brahmagupta was the first one to worry about zero as a number and worried about the question of addition of zero and multiplication by zero, etc. He took zero as a number seriously for the first time, and that is why Indians get credit that we do today, because he was the first one to define the algebra of zero. The whole idea of algebra was essentially an Indian construct, but till then everything was either arithmetic or nothing. So the students of equation enhanced their importance by defining the zero of an equation, which we do now. They did not have zero of an. So fx equal to zero kind of equations they did not solve. They just wrote down various series and they solved it for under various conditions. So for example, what does 1 plus 2, 1 half plus 1/3 plus 1/4 look like, and things like that. Zero was received its due recognition and it's important, and therefore he comes out with zero as an entity. Why does Indian mathematics arise this way, etc., are another set of interesting questions, but that I will answer in my next talk later in the evening. And the answer is precisely because Indian mathematics begins differently from the origins of mathematics in other cultures. And we will look at those issues in the later talk. In the later talk in the evening today. It is for this reason that Indians are credited with inventing zero. They did not invent it in the sense that they were not the first one used, but they understood it, they explained it, and they used it and got the whole world to work on algebra of zero with zero. So Bijganita explicitly says that x plus 0 is equal to 0, 0 plus x is equal to 0. 0 is an identity element with natural respect for additions. Subtraction, x minus 0 and 0 minus x. X minus 0 is x, but 0 minus x becomes minus x. He talks about multiplying with zeros. X into 0 is equal to 0 into x is equal to 0. He defines actually 0 upon x as an for non-zero x. He says that is undefined. For x upon 0 also he says it is not defined. So the later algebra would work on these problems, but they would do that. But interestingly, he said 0 upon 0 is 1. So 0 was so real to him that 0 upon 0 became 1 for him. Later algebraic rules for development of algebra, taking 0 upon 0 as 1 was not consistent, so rules were changed, etc. But within the framework of Bijganit, 0 upon 0 being 1 was not silly. It was completely consistent with the mathematics of that time. Later, when you use in physical entities and when you say that 1 upon x is the nth part of a upon b means something is divided into b part out of which a are being considered, when that kind of physical interpretation of ratios comes in, then of course 0 upon 0 makes no sense. But that is a later diversion. It doesn't speak in any way poorly of what Brahmagupta did. And exponentiation of 0 also says, he says x raised to 0 is 1. Except of course when x is equal to 0 itself. And he says 0 raised to x is 0. He actually goes on all the way up to exponentiation in order to explain algebra. And on this algebra, later on things are built up. For any function fx, the equation fx equal to 0 holds a special algebraic rule, but this is not what they used. It's interesting the Indians didn't use it because to them Indian was mathematics was a language. So they were worried about various kinds of series and sequences rather than physical situations where fx equal to 0 becomes an important issue. Because the emphasis was different. The best illustration of is in the set theory. The best way of understanding the entity of 0 is to understand that the set with 0 is different from null set. That's when you first realize the importance of 0 as an entity. And these basic rudimentary ideas of set theory actually exist in the 5th century AD, or that golden Siddhantic period of Indian mathematics. Set theory explicitly states out that a set theory with 0 as an element is not a null set. Indians solved equations like fx for x equal to 0, but not fx equal to 0. And that was because they didn't need it. Originally, they defined 0 upon 0 as 1, like I said, So 5 into 0 upon 0 would be 5. That they would not. But that is the convention they used, and they were consistent in using that. Ultimately, when mathematics became a tool of physics, this definition had to be changed. However, this was changed when the limiting value theorems were defined and mathematics became a tool. So you realize that when you write an equation of limit of x equal x upon y, where x and y both tend to 0, will reach 0 differently because x may behave differently from y, and therefore defining 0 upon 0 in this case will depend on how x approaches 0 and how y approaches 0. So you have that L'Hopital's rules and so on, which you are useful when you're doing physics with mathematics with, or rather physics with mathematics. The problem arose only when the idea of instantaneous and average speeds, etc., came into being. So the Indian mathematicians never had that problem, and they were quite consistent with 0 upon 0 being 1. India would have reached here only after planetary orbits, etc., much later. At the time of 500 AD, this was an excellent formulation to go forward with. Then 0 as a null entity that created. So what are the forms of 0? 0 as a null entity that created the universe, it exists. 0 of meditation exists. 0 of grammar exists. 0 of mantras exist. 0 of Atma and Mana exist in Vaisheshika. 0 of Anu exists also in Vaisheshika. In Bij Ganit, 0 is a proper mathematical entity. And zeros that started out as Shunya become Sifar in Arabic and eventually become 0 in Europe. So it is the same idea that is transmitted. And we will talk about these transmissions of ideas and so on in the next lecture. So what is modern 0? It's worth looking at what is modern 0. 0 today in science represents neutral. If all the forces balance themselves, the net force is 0. Natural as in balance of forces in physical and real entity. In terms of any particular property of acidity or basicity, pH equal to 7 is neutral and so on. Biology, it means balance of stresses and forces. In digital electronics, 0 simply means very low voltage. So you have this digital electronics where plus 5 volt is 1 and 0 volts is 0, but 0 can be easily be plus minus 0.5 volts. And 5 also can be plus minus 4. It can be from anything from 4.5 to 5.25, depending on your electronic circuit. There are only 3 zeros in science. There is a 0 in the mass of photon. It's an absolute 0. The second absolute 0 is in the charge of neutrino. It is again an absolute 0. And the third 0 is the temperature, the unreachable temperature of 0 degrees Kelvin when the entire universe freezes over. These are the only 3 zeros in modern science. 0 of a perfect vacuum is imagined and used in physics, but essentially it is always a certain value. It is never really empty. You talk about vacuum fluctuations, etc., but that is a different set of issues. The physical zeros, measurable zero, experimental measurable zeros are only 3. Okay. Physics has a lot of artificial zeros, such as 0 of centigrade scale and so on. In astronomy, 0 is singularity with infinite. In astronomy, for example, 0 is a singularity with infinite mass and 0 volume. And when we talk of black holes, we'll come to something similar to that. I'll come to that in a minute. The object an object like photon moving with speed of light will always have 0 mass, and that is another possible primordial 0, if you wish. So let us look at, we now even talk about errors in 0. Like I said, 0 in digital electronics, 0 can be anything from up to 0.5 volts or more depending on your electronics. In computer science, 0 uses number is connected to circuits. So in computer science, when you begin with registers and storing things in register, the first register address is 0. And it is essentially binary mathematics, 0 and 1, and therefore 0 is central to the whole thing. And computer science, in that sense, for the first time, genuinely becomes the first number in the counting system because the register invariably begins with 0. However, the development also has meant that computer science also has meant that the 0 has lost its meaning in some sense of the word. So while the registers begin with 0, 1, 2, 3, 4, and so on, look at the numbers. Okay, in number, leading zero makes no sense. So 0, 1, 2, 3 is simply number 1, 2, 3. 0, 783 is simply 783 and so on. Leading zeros make no sense. But in passwords, in OTPs, in everywhere else, zero makes a sense. So you can have an OTP which says 0707 and it will be perfectly valid. Leading zeros also have a value because in that sense, zero has lost its structure, its importance. It is no more a representation of null. It is just one of the many symbols, 0 to 9 symbols that we use. But like all numbers, it has no value and simply used as a label. So computer science both gives legitimacy to zero by starting its registers with zero and loses its and identity because leading zeros make sense, for example. Okay, zero is simultaneously becomes the first number and simultaneously loses its value. It's fascinating how computers use zero. So zero has multiple philosophies. So there is a philosophical zero of the great creator. There is zero of grammar. There is zero of mathematics. There is zero of science, and there is a zero of computers. 5 different structures. All of them use the idea of null or non-existent in a completely different manner. Philosophy says the universe came from non-existent. Grammar says you can make some sounds non-existent for comfort and creativity. Mathematics says zero is a number and it's used to be used as an algebraic. It's a perfectly complete language of algebra which uses zero. Science is simply talks about zero as balance of forces and nothing more. And computers talk about zero simply as a label. The same zero has completely different structure and shape depending on how you talk about it. In the next, just to complete zero lovers connection with zero, you have zero in religion, philosophy, meditation, music, Sanskrit grammar, null points, etc. And you can see how they are connected. So all the zero of religion, I'm sorry, I don't know, think you can see the slide properly, but all the zero of religion are essentially connected. So you can put their connectivities, feed it to the graph plotting unit, and you can get an interesting feature that all zeros of religion are very strongly interconnected. All zeros of grammar are strongly connected. All zeros of metaphysics are strongly connected. All zeros of abstract nature are strongly connected. All zeros of physical or mathematical nature are strongly connected. And music, meditation, and formlessness of zeros also gets connected. But in turn, none of them are independent of the other. Each of them feeds to the idea of the other. And together they make this world of zero, which is complex, multi-layered, multi-structured universe of its own, if you wish. But I want to talk about in the remaining time that I have, I want to talk about zero and cultural responses. So indic roots of zero in modern mathematics, and Herman Weil openly acknowledges. He says the accidental zero has followed the course which seems to have originated in India and was transmitted with additions to us by the Arabs, and it is a concept of numbers that appears logically prior to the concept of geometry. It really is not all that correct, but at least it algebra predates European development of mathematics. And the Arabs, actually, I must confess that even though the numerals today are called Arabic numerals, Arabs themselves are very honest. So there are records which says that look, this new mathematics that has been developed in India seems phenomenal, and let us adopt that mathematics. And Arabs adopt it and call it Indian numeral systems, and they use zero, and they're very fascinated by zero and the algebra that comes with that. But when that knowledge gets transmitted to Europeans, the Europeans get it from Arabs, so they call it Arab numerals. But Arabs themselves are intellectually very honest in crediting the Indian civilization for it. There are two ways. So Richard Feynman, on the other hand, I hardly need to say who Richard Feynman is. He says there are two ways of doing physics: the Greek from the first principles and axiom, and the Babylonian, which is related one to the other. And he says, I am a Babylonian. I never have preconception of nature is like and or ought to be, and let nature tell me what is going on. And I'll give you one more set of quotes which are interesting later. So Europe found zero very unnerving and would not accept its existence. Since everything, like I said, was created by the one, they did not accept the idea that there could be null as an entity because null would not exist. It was only in 13th century, 8 centuries after Indians invented the rules of algebra, eventually because of its elegance and because of the pressure from Arab scholars, Europeans reluctantly accepted arithmetical zero or algebraic zero, but for a long time it was taught surreptitiously because the church would not allow it, saying that there was this great one and you cannot replace the entity of the great one. It was only in set theory and zero and null set that zero actually got properly investigated. They did not need the philosophical zero, so there was no question of that. But the mathematical zero also, they took a long time. Linguistically, they still struggle to accept zero. So, for example, I'll come to those examples a little later. But zero made a spectacular comeback in science because, like I said, there were a variety of things. So, for example, even in black hole, which has finite mass and zero volume, is called a singularity instead of a null point because of the discomfiture with this idea of null. But they solved equation like fx equal to 0, which provided a lot of insights, especially when mathematics became a tool of sciences. On its own, it didn't need that. It was just a curiosity. So there are at least 7 major differences between Indian and Western thought that may explain the differences in response to zero between Indians and Europeans. Traditions of worship. The great one was worshipped as the great one who was omnipresent, while in India it was not, and the ancestor worship also added to this idea of zero. But Nasudiya Sukta would be a profoundly influential piece of poetry. Disposal of mortal remains also required various things. So, for example, in Europe, there were mortal remains were formally buried and a track was kept. In India, it was not. There are 6 different ways of disposing the dead, including one that says that you leave it to animals and so on. And cremation is the most common one. There are burials, but then the burials are not marked because they were essentially nomadic. Traditions of oral transmission of India produced a whole variety of range of ideas which Europe would be deprived of. Rhythms, wordless mantras, etc. The idea that you could have poetry and music comes much later to Europe. Wordless poetry in Europe. Definition of what is knowable is also something very different in Europe and India. Meditative rather than argumentative nature of religion is also something very distinct. And tradition of inductive thinking rather than deductive thinking also made a lot of difference. And I'm going to talk about this inductive and deductive thinking because it has profound influences. Indians were essentially inductive thinkers. Something looked similar to something, and therefore things were happening. While as Feynman said, the Greek way of doing things is to write down formulae and do it. So Europeans were essentially deductive in their logic. They identified some principles and understand that other behaviors are based on these axioms. So you have Newton's laws of motion, and then everything else follows from there. It's a very powerful system and produced a lot of innovations that inductive system would not have produced. But that's a different story for some other time. It is a rigid system and has led to remarkable progress from 16th century, the entire Renaissance period. Indian logic, on the other hand, was inductive logic derived from information and comparison. For example, the deductive logic of, I'll give you a concrete example of what is this deductive and inductive logic. So in deductive logic of Europe, there is a universal premise which says all humans are mortal. And then it says Mayank is a human, and therefore Mayank is mortal. It's a straightforward thing. Compared to that, the other classical example given in Indian context is that there is fire on the hill. And because there is the reason why you think there is a fire on the hill is because there is smoke on the hill. And for example, in the kitchen, you have fire in the smoke in the fire, and therefore smoke in the hill also is a similar phenomenon, and therefore there is fire on the hill. And we know that water does not have smoke. So there is an example, there is a counter example, and therefore there is a deduction that because there is a smoke on the hill, there is fire on the hill. To take the examples cross, in the case of universal premise of all humans of the fire in deductive thinking, deductive thinking would simply say that fire produces smoke, there is smoke on the hill, and so therefore fire. So there is no positive example, negative example comparison. On the other hand, for mortality, they would say all humans, the inductive logic would say all humans are mortal because death is inevitable. And like my relative and unlike a tree, since I'm more like my relative and less like a tree, I will also die. There is that difference in logical system, by the way, essentially changes our approach to everything in the universe. And even in 21st century, this difference between Indian and European thinking comes to the fore. Okay. Deductive logic never produced anything interesting, says Bertrand Russell. Okay, whereas inductive thinking gives a lot of new insights. And so, in inductive logic, positive example establishes the inductive connection between two terms. There is smoke in the kitchen, and there is fire in the kitchen. The negative example denies, saying that it is not something else. It is the smoke equivalent to the smoke of the fire. And the reasoning does not proceed from a particular to particular. So statement A, B, C are true because they have a common thread to be true. It is not that because A is true, B is true, C is true, and so on. Deductive logic, on the other hand, says that since A is true, in all cases that A applies, everything else is true. So it is forceful, but less creative. As a result of this difference, a well-formed as well as informal discrepancy between deductive and inductive methods, attempts to connect the two synonyms have been very difficult. So the approaches of the two cultures to thinking, etc., have been difficult to. So there is a hodgepodge of things that come in when it comes to trying to merge the two ways of thinking about nature and its working. The Greeks also considered this, but were overwhelmed by Aristotle. So, but Greeks also initially had inductive, because inductive thinking is logically simple, earliest, because I mean, you have seen this fire and you have seen the smoke, and if you see smoke on the mountain, obviously there is fire on the mountain. It is more logical. But Aristotle singularly was so effective, and his students were so effective, and they hated the idea of nothingness, that they forced their thinking into the entire Greek system, and it remained uh, deductive since then. So just as Nasidiya Sukta would change Indian philosophy to a particular way of thinking, Aristotle and his students would change their own thinking. Okay. So Paul Dirac was a very classical deductivist. He says it is more important to have beauty in one's equation than to have them agree with experiments. He says my equations are more intelligent than me. Feynman, on the other hand, says that I worship a phenomenon, not an explanation. Do not tell nature what to do. Do not say in nature you must obey Newton's laws of motion. Let nature tell you what it is doing. A very great deal more truth can become known than can be proven. So, unlike the completeness of Dirac's opinion that everything can eventually be expressed in mathematical language and we will have a complete theory, Feynman says no. He says no because inductive thinking and the way nature works has its own limitations of how much you can really think. And remember, they are both great European physicists. So the general comment is that the rational and the intuitive were not as divorced in India as they were in the West, and hence disparate logics could be developed in India. So this idea of Ardhanarishwar, etc., comes from the same thing, that contradictory ideas can be held together. The relative open-mindedness of India permitted the invention of zero, whereas Greeks and Europeans denied themselves this greatest of inventions. The West adopted zero only functionally and for its utilities, essentially for mathematics, without having to internalize that philosophical significance, or what they still find repugnant. So nihilism, or idea of nihilism, etc., is not accepted. It's considered Buddhist or something. It is an awkward state of affairs that continues to date, and the idea of study of this form of zero encounters a lot of ideological resistance in academic circles, even in Europe today. One can also have similar analysis of infinity. Just as I've given you the lecture on zero, I can also give you a lecture. I mean, I'm not knowledgeable enough, but in principle, one can sort of work out the chain of infinity also, because infinity is simply a mirror of zero. So just as Europeans hated zero, they also hated infinities. Well, Indians loved infinities. And so essentially for Europeans or Aristotelian thinking, everything was geometry, and all geometry was closed and finite. So the idea of infinities again was something they didn't like. The bottom line is that science prides itself in being cultural, independent, and absolute. However, cultural sensitivities give different insights. While rationality and experimental confirmation can be the only arbiters of validity of any scientific institution on the working of nature, one's perspective can significantly vary depending on one's cultural background. So even though there is no doubt that rationality and scientific experiments should be the only way of validating a scientific idea, um, how you think of that problem actually is culture sensitive. So, for example, the Director General of CERN, once I was talking and we had taken some students and all that, and we were talking, and he said if he had if he had a PhD program which required a lot of physical labor and mechanical work, he would naturally select a Chinese student and would never take an Indian student. On the other end, if he had a PhD project which required a lot of thinking and analysis and figuring out things, he would never take a Chinese student but would take an Indian student, because Indians are used to this kind of sitting down for themselves and figuring out things much more than being fed that information which is typical of Chinese culture. So even in 21st century, poetry is written 3,500 years ago and philosophical ideas created 2-3,000 years ago still define who we are and how we are. It is therefore important to be original and creative in thinking rather than to be swayed by cultural ethos. It is good to keep your independence of thinking. Uniqueness produces unique perspective. So of the Europeans and Indians, if you are an Indian, you will ask a question like, how can something as simple as zero be so complex? And if you are a European, you can ask that how can an entity that represents nothing can itself have an identity? Europeans have that problem of identity of zero. How can something that represents nothing have an identity? Well, Indians would say that zero is everywhere. So why is it so complicated to have zero? Thank you very much. That's all I wanted to say. And we can have questions if you wish.
Sir,
Even if the comment says I didn't understand a word of what you were saying, that's also fine. Yes, sorry.
uh,
Somebody was saying something.
yes, sir. Yeah,
Yes, Suraj.
if let us suppose if zero will not be there, suppose.
Uh,
So what will happen? What will happen to our a
so
lot of
what would happen?
physics?
Yeah, physics would be in serious trouble. Physics would not have reached Newton's laws on the ones the Renaissance period came. That algebra would not have developed without zero, accepting zero as a genuine entity. And understanding limiting value theorems, etc., would make no sense in the Aristotelian thinking. It would only make sense in the background of an algebra where zero is a genuine entity. And
Yes.
descriptive physics will only go this far. It will not go very far. So essentially,
Yeah,
the
because
Renaissance period does not happen.
yes, sir. For
Yeah.
example, sometimes we are talking about at very low temperature, that is nothing but zero temperature only.
Yeah.
And a lot of people, for example, starting from devise theory of specific heat also.
Mm.
And many more
Yes.
other examples are like in different fields.
So science incorporates zero really carefully, really lovingly, and really thoroughly. Zero exists everywhere in science, but that is a 16th century science.
Yes, sir. But it is
So
really very
there
interesting.
is,
Yes, sir. Yes, sir.
yeah. Thank you. Uh,
Yes.
do you have any question? Because somebody in the group,
Yeah, yeah.
somebody
Please,
on
sir.
the chat has a
I
comment.
am done, sir. I am done. Thank you.
Okay, thank you. So there's a question about how the ideas flows from it. So Indians and Europeans, especially Indians and Arabs, have a history of communication right from earliest period. You know, Harappans traded with the West Asian Sumerians and others. Um, we know, for example, that there are temples of Ganpati in Europe, etc., and all that. So cultures, and there is Gujarati text has been found on a temple in West Asia somewhere and so on. So Indians and Arabs had a very close connection, and in fact, if you have not read it, you should read a book called India by Al-Biruni. So Al-Biruni was this profound and very intelligent scholar who was sent to India to study India, and his book is now available. It is called Al-Biruni's India. It is now available in English, and he has to pay respect to Islam. So he sort of, at the end of each sentence, he says, "But still, Allah is great." But in his analysis of what Indian thought was, he's very profound and very precise and very clear, and it gives a very positive and very strong impression of how good Indian thinking was. He also notes that these Indians are great thinkers and have great ideas, but they have become so xenophobic that eventually it will lead to their downfall. And sure enough, in 200-300 years, the culture comes to a standstill because we become xenophobic and unwelcoming of external ideas. But Al-Biruni actually in 10th century AD notes this down. The 13th or 14th, by around that time, the whole mathematics goes from India, and there are discussions in Arabic about how this Indian mathematics is interesting and how we should adopt it. And they adopt it and build up on it and create profound algebra. And in 16th, 15th century, once Europe starts coming out of its dark ages after the fall of Constantinople, all these ideas are transferred to the Europeans. So the Indo-Arab connections have been very old, very detailed, and very well documented by Arabic scholars. And like I said, Al-Biruni's India, etc., actually shows you how this is done. And then it develops and so on. Okay, I hope I've answered your question. Somebody else has raised a hand. And
Dr. Sinha, I think. Dr. Sinha, would you like to ask your question? She had raised her hand.
Yes, sir. I'd am I audible, sir?
Yeah, audible.
Yeah. So thank you very much, sir, for your nice presentation.
can't
And
hear you.
I was very, you're going to tell something regarding zero with black holes. So can you please elaborate
Yes.
regarding the matter?
Oh, okay.
So,
She said,
okay.
zero and
So
black
black
holes.
hole is a
Can you
yeah. So
elaborate?
black hole is a very weird entity. I don't know how much of physics you know, but I'm assuming that you know. You don't know much of it, but the black hole is a very interesting entity. Now you can imagine that if you want to escape from Earth, you have to send a rocket at about 11 kilometers per second. If you want to escape from the sun, you have to send a rocket at about 400 kilometers per second, and so on. So the bigger the object, the higher is the escape velocity. So you can imagine an object from where the escape velocity exceeds velocity of light, and therefore not even light will escape from it. And that is essentially what a black hole is. And if you look at the algebra, and our algebra is very limited in this case, you essentially end up saying that the mass would keep on falling at the center. It would be a finite mass. You can measure the mass of a black hole, but the volume that it would have according to our algebraic equations is essentially zero. It is not exactly zero, but it's very close to zero. Quantum mechanics, we believe, will prevent it from becoming absolute zero, but it will be very close to zero. So that is what a black hole is. Now, for the universe and things around it, black hole is the ultimate end to everything. Anything that falls into this black hole essentially disappears forever. I mean, in a broad sense of the word. So that is a kind of entity that black holes are, and therefore, in all fairness, that is where the universe's entities end in any real sense of the word. So it is, to me at least, it's a 0 point. But to physics, it is a singular point. But there are interesting problems that come up with black holes, which are fascinating in the sense that even if the escape velocity from black hole is zero, is greater than velocity of light, as you go a certain distance away, the escape velocity will be less than velocity of light, and therefore light will escape from there, and that is called event horizon, etc. Philosophically, how black hole is handled is a different question. I think it is still in the realm of science, and we use the word black hole simply as something where everything goes to die. So, for example, Bombay University's examination section is a black hole. Once you submit your paper, you never know whether it will ever come out or not. So in that kind of philosophical context, we use it. But otherwise, it has not really got into the philosophy, because even physicists really do not know, because their equations essentially stop once they cross this edge or boundary where the escape velocity is more than velocity of light. We really have no idea of what physics inside will look like. We have some guesses, but no provable ideas. So physics, black hole, at least as far as I know, is still in the realm of physicists trying to make sense of what this entity is. And the word black hole in literature is used only as something where everything disappears forever. And one can talk about philosophy of the universe and so on. That's a different story. I'm not an expert on that at all. So I'm not so sure I've heard you completely, but I've tried to respond to you as much as I can. There is another question. The transition from nomadic to sedentary society in India has limited the scope of inductive method What do you think? I don't think so. I think inductive thinking is something that we still routinely use everywhere. Similarities in trying to explain everything is still there. The idea of comparative is ever there. Argumentation and discussion, whether the whether you see something is smoke or not, and whether it is related to fire or not, or whether it is the mist that you see on top of a lake or something, on a cool lake or something. So those kind of argumentation still happen. What is similar to what is not an easy question to answer in many contexts. And so therefore those debates continue, those simile ideas continue. Many religious issues come up like that, and so on. So inductive, the way we fundamentally think is very built into our language and culture. I mean, I could give some example, but not very good ones. There are better example that, for example, when you talk of freedom in English, it is called independence, dependence on nobody. The corresponding word in Hindi is swarajya, self-dependence. So the nature of self-discipline gets built into the language. And then I'm sure there are much better examples to show how inductive logic still plays a critical role in our thinking compared to what a purely European, grown-up European centered thinking person would do. It is neither right nor wrong. It is just a way of looking at the universe. There's no rights or wrongs in these things. The question is from Jayesh in the chat is whether it is related to wormholes. Wormholes are supposed to be the antithesis of black holes. That is where things come out from the universe. The problem is that our physics does not at all permit these wormholes. We have never seen anything approaching a wormhole. The physics is very dicey and does not approve of it. And they're just nice things to create for science fiction writers, but wormholes don't really exist. In principle, if they existed, they would be antithesis of a black hole. Yes.
No, I think this black hole concept, I mean, it was the solution of Einstein's equations, right? And the idea of something which is point-like and yet can have, millions of times
Mass.
massive than the sun is something enigmatic. Maybe we learn something more as we, with time. But right
Yes,
now,
yeah, we will.
we lose all information once we go beyond a point where light cannot escape. And whereas wormholes, as Professor Vahia just said, is also a mathematical solution, but whereas we have observational evidences for existence of black holes, we have absolutely no observational evidence for existence of wormholes or white holes.
Yeah, and our best hope of answer is when quantum mechanics gets synchronized with
gravity.
Yeah. Right now it doesn't.
Yeah.
But there are some, so if you believe in quantum mechanics, black hole or no black hole, then you have some interesting possibilities for black holes, but they are not testable and therefore they are not science.
Mayank, this Dr. Barak's question on transition from nomadic to sedentary life. I mean, it's an interesting question because, what you're saying is okay, but when they were actually nomadic, whether they had to rely much more on generalizing and relying on inductive logic than was required later when they settled to a sedentary life, is sort of an interesting thought, isn't it?
Yes. So what happens? Okay, I mean, this is something that is actually a field of my personal current fascination. So I believe that the nomadic Rigved writers were not from India. They were from Central Asia. Tilak makes this point very beautifully, and modern data is consistent with that. And then they would get horse around 3800 BC, and then they would travel to India through Khyber Pass and so on. So when they come to India, there are already well-set intellectual streams. Harappan civilization has just about died, but the formal ways of thinking already exist. And they merge the two very beautifully in later literature to create the science that we will see in the next lecture. So it is not that they were isolated. They were isolated when they developed inductive thinking, but they are no longer isolated when they are now extending that to physical world. But they continue to use this inductive method in a very elegant and beautiful manner. So I will talk in the next lecture about this book called Vaisheshika, which is the first book of science. It is also inductive in its approach to understanding how nature works. So and algebra to them, see, a deductive logic becomes so Europeans, for example, at the time of Aristotle, etc., also tried deductive logic, but they don't get very far because they didn't have the foundation of knowledge and they didn't have the foundational mathematics. Deductive language becomes powerful when you can write down the principles of deduction in mathematical format. Mathematics at the end is a language created by humans. It's the most perfect and precise language. And when you translate anything into that language, it becomes much more insightful. If Newton had simply said that time evolves in the way that his equations give, it would not have got anywhere. It is because you could now quantify things that you started changing things. That mathematical approach to understanding nature, after all, till 13th century, Europeans also remained inductive. I mean, they became deductive, but they weren't very sure. In fact, they were into their dark ages, and it is only from the Arabs that they would learn about their great past and the idea of deductive thinking and Aristotle and all that. And it is then that they say that, okay, wait a minute, if Aristotelian approach was deductive, let us see what deductive approach gets you. But the foundational basic knowledge comes from inductive thinking. And in India remains inductive even when formalizing science. And how they avoid that, how they don't get into this deductive thinking is an interesting question, because the creators of mathematics were elites and they never mixed with artisans. And therefore, they never needed to create Newton's laws of mechanics. They could have done that 3 centuries earlier. But they only use it in astronomy, which is itself pure, and they use it for mathematical funs and games. So that need for the idea of that deductive logic works only when there is a mathematical foundation. And Indians use mathematics as a language and never used it as a tool. And that is where the problem comes in. So nomadic or settled, Indians continued to be inductive, and Europeans said, okay, let us use a deductive method, and started writing equations. And they used mathematics as a language to understand the working of nature. And that changed things. So there is a little more complication than simply settling down and being a nomad.
Yeah. I mean,
It's a long answer,
course,
so I do not know.
No, it's okay. Aristotle, of course, got several things wrong by just relying on deductive.
Oh, yes.
Ultimately,
Exactly. He did. So, for example, he insisted on the world being... that is also an interesting question. So he had this cyclic theory of movement of planets. Then he said, okay, there are epicycles, cycles on top of cycles, etc. And they spent enormous amount of energy doing that, in trying to get the circle into circle into circle for planetary motions and all that. Aryabhat, on the other hand, simply says that, look, algebra, the planetary motion obeys this equation in for all practical purposes except for this little time. Why it happens, they don't bother. Because there is no similarity to what happens in the sky to what happens on Earth. And therefore, they are not obsessed with the idea of creating a geometrical image of how nature works. When it cannot be done, it cannot be done. So there is no simile, etc. It cannot be done, and therefore, by the time of Aryabhat, they are essentially now using mathematics, but they are still using mathematics only for nature, for heavens, not for nature in general. If they had done it for nature in general, but because the Brahmins never went and sat with the artisans, and that remains the bane of Indian science. Historically,
I mean, that was highlighted quite nicely by Meghnad Saha as well, right, in his writings.
Yes,
how the
it has been highlighted by various people. It is not my original idea. Many people have written, even some people from TIF have written articles in IHHS, etc. And that remained the bane of Indian science. But we were inductive when we continue to be inductive in our thinking. For example, the carpenter who comes to your house to make a piece of furniture, he's not a deductivist. He does not say the wood has this kind of tensile strength and aluminum has this tensile strength, and therefore the amount of stress that the window will face will be so much, and therefore I will use in window aluminum or wood or whatever it is. He's completely inductive. This works, so I will use it. That is another completely different set of questions.
Thanks very much, Mayank, and thanks very much to all of you.
My pleasure.